Features of the tangent and cotangent graphs. Let me make a couple of general comments first. Obviously, in each case, that basic shape just repeats itself over and over and over between each set of vertical asymptotes. In terms of committing something to memory, we'll call this marked out section the fundamental cycle of the tangent function. It's the part that goes between negative pi over 2 and pi over 2. There are asymptotes at those ends, and then the shape goes up between them. Also, you'll see on this graph I've marked what we'll refer to as the 3 key points. We'll want to mark the point that's right in the middle. In this case, that's 0, 0. And then we'll want to mark the 2 points halfway in between that middle spot and the vertical asymptotes. That's these two, which in this picture would be pi over 4 comma 1 and negative pi over 4 negative 1. Notice that the tangent function moves upward from left to right between the vertical asymptotes. Let's make some similar observations for the cotangent function. I've marked out what we refer to as the fundamental cycle of the cotangent function. Notice it's a different section. For cotangent, the fundamental cycle runs between 0 and pi, two of the vertical asymptotes. There are still the 3 key points. The middle point here is at pi over 2 comma 0. And then the halfway points, we've got one here and one here. Looks like pi over 4 comma 1 and 3 pi over 4 comma negative 1. And notice for cotangent, between the vertical asymptotes, the graph falls from left to right. Okay, so what about the period of these two functions? Well, we know that the basic shape just repeats itself between each set of vertical asymptotes. So if we can just figure out how far apart the vertical asymptotes are, we'll have the period of our function. For the tangent function, let's see, in that fundamental cycle, the asymptotes go from negative pi over 2 to positive pi over 2. What would that distance be? I could just subtract to find out. These would plus out. Pi over 2 plus pi over 2 would be 2 pi over 2, which of course is just pi. So the period of the tangent function is pi. Every distance of pi, the whole graph repeats itself. The cotangent function is even easier to deal with. Once again, the whole shape repeats itself between the sets of vertical asymptotes, and I can see from 0 to pi here, obviously that's a distance of pi. From pi to 2 pi, that's another distance of pi. So the cotangent function also has a period of pi. One issue that we're going to have to remember when we start stretching these things out and changing the period, we've had that little formula, p equals 2 pi over b. The 2 pi was based on the regular period of the sine and cosine function. For tangent and cotangent, that means our formula is going to be p equals pi over b. So we're going to have to be careful with that when we're dealing with the tangent and cotangent functions. And then how about the range? Well, this is pretty easy because at the top and bottom of these graphs are arrows. They just go on and on forever in both directions. Every single y value imaginable shows up on this graph somewhere. So the range is just all real numbers. I'll write negative infinity to infinity for interval notation. And of course, it's just the same for the cotangent function. All real numbers, negative infinity to infinity. How about location of vertical asymptotes? Well, we know how to do that now. They're all vertical lines. They're all going to be x equals something. We've been taking the first one, the nicest one. When we say nicest, we basically mean the first non-negative one. For tangent, that would be pi over 2. So the first one is pi over 2. And then we add to it multiples of the distance between the asymptotes, which we've already learned is pi. So if I add 1 pi, I'd get to 3 pi over 2. If I added negative 1 pi, I'd be back here at negative pi over 2, and so on. This would find me all of them, k standing for an integer as usual. For the cotangent function, let's see, the first non-negative one would just be here at 0. That's certainly the nicest one. So the starting would be 0 plus multiples of the distance, which was once again pi. And obviously this one simplifies a little bit and is just x equals k pi. Remember that the domain of these functions is connected to the location of the vertical asymptotes. We can stick in any x except where there is a vertical asymptote. So for the tangent function, the domain would be anything except the numbers pi over 2 plus k pi, and for the cotangent function, all x's except multiples of pi. And then lastly, let's talk about the symmetry of these graphs. It's not too difficult to flip the thing upside down and see that you get the same exact picture. So that means this graph is symmetrical across the origin. In other words, the tangent function is an odd function. Well, the cotangent function is just the reciprocal of the tangent function, so the same thing is going to happen here. If you flip around this graph, again, you can see that nothing has changed. We get those same downward from left to right shapes, so cotangent is also an odd function. Let's see how the calculator handles these functions. I'll put in y equals tangent x, and I'm thinking the z-trig window will probably be a good one. And sure enough, you can see those upward from left to right shapes that we were getting with tangent. Of course, the calculator doesn't show the asymptotes. They're there. You need to show them. Let's see, z-trig counts by pi over 2. So here's pi over 2, here's negative pi over 2. If I drew in those vertical asymptotes, this section here would be the fundamental cycle. Pi over 4 is halfway to pi over 2. That would be about here. Here's pi over 4 comma 1. That's one of the three key points. Here's negative pi over 4, negative 1. You can try the cotangent graph yourself if you would like. You'd have to type it in 1 over tangent x. Thanks for watching.